1, 2, 1, 2.
Yes, okay. Welcome, everyone. I hope you're all having a good conference so far. Our next speaker is jmfriedt. He's an engineer at a French company, and he teaches at the university at master's level. And he'll be presenting about developing for embedded devices using open source tools, and with a specific focus to gaming consoles, small gaming consoles. So I'll let him take it away.
Thank you. Okay, the topic I wish to discuss today is generally, broadly speaking, the development of embedded device using operating systems, and more specifically, the use of game consoles as an example of platform on which to learn how to develop embedded systems. As mentioned, I'm trying, as an engineer, I have to develop embedded electronic system on the hardware and software level, digital and analog sides. And what I want to do here is try to share with you some of the aspects that I have to, some of the challenges I have to meet daily, but not on some obscure platform dedicated to medical applications or to some fancy corporate applications, but on handheld game consoles. I want to show you that these pieces of electronics that you surely have somewhere in one of your drawers can be used for better uses than just playing stupid games. One of the aspects of game consoles is that they are, as opposed to computers, to modern PCs, which are hardly understandable. I cannot understand how a PC works anymore. Since they switched to PCI, SATA, all these serial buses, I just cannot understand how a PC works anymore. What's really nice about game consoles is that since they are much lower power and usually based on older hardware, you will replace all these complex buses, all these optimized buses for speed, for cost also. They will be still replaced by our older parallel buses, and I will describe to you the hardware thanks to which we can communicate with game consoles. So one of the aspects of my presentation will be that game consoles are still based on hardware old enough to be understandable by common people, while being available, as opposed to, for example, these very old processors that are no longer usable. And the power that you have access to with game consoles is relevant to the kind of application that you have that you might meet in developing embedded hardware based, for example, on circuit boards or FPGA-based developments. Now, what I don't want you to think is that this is yet another presentation on another platform on which to run Linux. The first thing I'll show you is that Linux is not appropriate for many embedded applications. And secondly, I want you to see that there is a mix in developing embedded devices, a mix between hardware and software development. If you're just software or just hardware developer, you only meet half of the challenges. And what I want to show you here is that both things are working together. Now, the first topic I wish to discuss is the Nintendo DS. Historically, I started working on the PSP with one of my co-authors. But actually, I think the Nintendo DS, being older, is much more accessible. It also is more relevant, maybe, it's arguably more relevant to embedded design in that it's based on ARM CPU. The PSP that I will discuss later is based on MIPS. Now, the Nintendo DS has 2 CPU, and that also makes it relevant to embedded hardware because very often in embedded devices you will have multiple CPU dedicated to each task. And in this sense, the NDS is relevant because it has a main CPU, an ARM9 CPU, and the ARM7, which acts as a coprocessor for managing things such as display, sprites, touch screen, or Wi-Fi connections. So we will be developing exclusively on the ARM9 CPU. You only have access in injecting software on the ARM9 CPU, while the ARM7 CPU will still run all the procedures provided by the manufacturers of the Nintendo DS. We have 4 megabyte RAM in the DS and DS Lite, the newer DSi that I would strongly advise you to avoid because they have removed some of the hardware port that we'll be using. So the DS and DS Lite have 4 megabyte RAM, and this will imply some constraints on what we can do and what we cannot do. We will see later. We have Wi-Fi interface. We have no asynchronous RS-232 ports. This makes it a bit awkward compared to most microcontroller developments. When you develop a microcontroller, the first